Hey guys, what is up? So this is a new video and I know I haven't been posting for the past 2 weeks. A lot has been going on. But anywho, today we're going to learn about physics and we're going to learn about chapter 4 from 4 physics. So I've tried to simplify the whole chapter for you guys so it's easier to understand and easier to sort of learn the chapter. This video will probably suit the most for people who are trying to revise the chapter or trying to just get an overall view of what the chapter is about. So there's two things you need to know at the beginning of the chapter. One is to differentiate temperature and heat. Okay, so what is heat? Heat is a form of energy, and as you guys know, energy, anything related to energy, it's the SI unit is joule, and then the symbol is capital J. And temperature, how do you define temperature? It is the measure of degree of hotness or even coolness of an object. Now, SI unit dia bukan Celsius, it's actually Kelvin with a capital K. Okay, so remember, heat is a form of energy, whereas temperature, it's to measure the object itself. How hot is it, or how cold is it? So here is extra knowledge. Object heated is basically absorbing heat, and is also known as endothermic, but this term is not really important, but it's good to know. Then object cooled is releasing heat, which is exothermic. Touching this part of the chapter is thermal contact between two objects. So what does thermal contact mean? It means when two objects are in contact and heat energy can be transferred. Because there's three. Heat can be transferred in three ways. It's conduction, convection, and radiation. So conduction is transfer of energy from one molecule to another by direct contact. So from solid to solids, you can view it that way. Whereas convection is the movement of heat or transfer of heat through fluid, such as water or even air, like water molecules. Okay, so radiation is the transfer of heat using electromagnetic waves, and we've learned related to electromagnetic waves in chapter 5. Take a look at this two object over here with different temperature. So one is 50 degrees, one is 100 degrees. So when they're in thermal contact, they are actually like that. In this case, it is through conduction because they're very close to each other. And see, it's like side-by-side solids. So what happens is the heat energy will get transferred from the hot object to the cold object. Kenapa? So it's always from hot to cold, from hot to cold. Hotter object eventually cools down, whereas the cooler object eventually warms up. So this hotter object, it will cool down to a temperature, whereas this cooler object will heat up to a specific temperature. And thus their temperature will be the same. So let's take a look over here, the explanation. So after some time, the heat energy is transferred at the same rate between two objects. So what happens is after a while, there will be no net heat transfer or net rate of heat transfer between the objects. So after that, it results in both objects to be the same temperature. And when both objects are in the same temperature, eventually it is said to be in thermal equilibrium. So that is basically what thermal equilibrium means. First point is both objects needs to be the same temperature in the end. And second point is there will be no net heat flow or net heat transfer between two objects. Because heat will always be transferred, but then there will be no net heat transfer. You have to add the no net, okay? Because there will always be heat transferring, but you have to specify no net heat transfer between two objects. Or you can also say the net heat of transfer between two objects is 0. In physics, I hope everyone knows the essay questions. So here are essay questions punya tips and tricks punya points if you guys want to have a look at it. So you guys can take a screenshot in 3, 2, 1 and probably write it down. So basically, you need to, your temperature, your thermometer, you have to have thin walls of the bulb itself. Why? To increase accuracy. You have to make sure the capillary tube itself has a small diameter so that it's more sensitive. And then you have to make sure that you're using a mercury. Because why? The mercury liquid, it depends, okay? Because it depends if you're in a hot or cold region. But usually we use mercury because it's opaque and it has a good visibility. And, or another point, it's because it expands uniformly. Next is to use a Celsius temperature calibration. It's because if you use Celsius, it's a more widely used metric unit to measure temperature. So depending if you're in a hot region or you're in a cold region, so if you're in Malaysia macam tu, you don't need to use mercury sebab you have to use mercury sebab dia punya range of temperature is from 0 to 100, whereas alcohol is more suitable if you go to colder regions because it can measure from negative something Celsius. Like it's basically if it's alcohol, use it in places that's more cold. For example, Antarctica. That could be an example. So thermometer, what happens when a thermometer does not have, I call it no garisan, but basically there's no line to indicate the actual temperature of the thermometer, whatever the thermometer is measuring. So where did it go, right? So now we're going to learn how to calibrate a thermometer. Okay, let's say the liquid is up here, which is 5 centimeters, but so that 5 centimeters is over here. But you have to make sure you minus the melting point. So 5 melting point, sorry, it's the ice point, the melting point, I don't know, it's up to you, it's up to the question. So let's say the point is at 2 cm, so 5 minus 2, we're going to put it here, 5 minus 2, and the length of the whole thermometer is 10 centimeters. So 10 centimeters, and you have to minus the point, remember? So 10 minus 2 is 8. So it is 3 over 8 times 100, and you'll get 37.5 Celsius. Always times 100, okay? So this is the 100 Celsius basically. For example, a question that's over here. So we know that, it's just an example, and we know that here is the ice point and here to here is 3 centimeters, but from the ice point to here is 12 centimeters. You don't have to minus anything, just take it from this point over here. So 12 centimeters over the whole thing from the ice point here until here. So it's 30, right? So 12 over 30 times 100, 40 degrees Celsius. So what happens when a thermometer is placed under your tongue? So thermometer, it can be clinical thermometer, it can be infrared, it can be mercury, but basically when it's placed under your tongue, same thing will happen, which is thermal equilibrium. Heat from the patient flows to the thermometer until temperature of the thermometer is the same as the patient. So the body temperature of the patient now can be determined because thermal equilibrium occurs. So both the thermometer and the patient have the same temperature, kan? So now you know, okay, what's the measured degree of hotness or coldness? The patient itself. This part of the chapter, which is 4.2, we're going to learn about the quantity of heat. Now the formula that you need to know is Q, which is the quantity of heat. Q equals to mc theta. Theta is basically the change in temperature, okay? So M is referring to the mass, make sure it's in kg. And then the C is referring to the specific heat capacity. We'll learn more about it later on. Then this one is the change in temperature, okay? So final tolak initial or the big tolak kecil. What is heat capacity? Heat capacity is the quantity of heat that is required to raise its temperature by 1 degree Celsius. Now, how does it differ by specific heat capacity? Anything related to do with specific, you have to take into account the mass. So specific heat capacity is the quantity of heat needed or required to raise the temperature of 1 kg of mass of the substance by 1 degree Celsius. Now take note, I am not going to explain in this video about what is sea breeze and land breeze. Do check it out yourself in textbooks or other sources. Specific heat capacity of aluminium is 900 joules per kg per Celsius. It basically means 900 joules is needed to increase mass of 1 kg aluminium by 1 degree. Means selagi dia tak dapat 900 joules tu, it will not raise its temperature per 1 kg too. Here is an example of a question, which is calculate the total heat absorbed by the copper of block mass 500 gram, which is heated from 31 degrees to 80 degrees. And then the soalan already bagi tahu that the specific heat capacity of the copper block is 390. So remember our formula, total heat, quantity of heat kita nak tahu, which is Q equals to mc theta. So because Q equals to mc theta, what is M? Okay, remember M, it must be in kg. So 500 gram ni kena tukar kepada kg, which is 0.5 kg. Okay, so 0.5 times, and then the C is for the specific heat capacity, times this, times the change in temperature, which is 49, because 80 minus 31. This will be your answer. And don't forget, because they are not heat, and heat is a form of energy, you can write a capital J there. The next type of soalan that they can ask you is something related to this. So let's say calculate specific heat capacity of the metal. A 0.5 kg metal block is heated by a 50 watts electric heater for 90 seconds. Alright? The temperature of the block rises from 20 degrees to 45 degrees. We know that Q equals to MC theta. They want to find out the specific heat capacity. But here's the problem. We have two unknowns. We don't know the quantity of heat. And we don't know what the value of the specific heat capacity, which is what the soalan is finding for. So we can replace Q, because Q, remember, it's quantity of heat. It's also a form of energy. But energy, there's so many types of energy, right? So electric energy is PT. P is for the power, which is calculated in watt. And T is the time in seconds. What we're going to do is just substitute this inside this. So now PT equals to MC theta. And right now, if you notice, we have only one variable left, which is what we actually need right now, because we are trying to find specific heat capacity. Because we know the value of P, which is 50, given in the soalan, and T is given in the soalan as well. See, 90 seconds. So we're just going to substitute it in and solve it. Eventually, you're going to get this answer. Don't forget your unit is joule per kg, so it's -1, and per Celsius, -1. 20 grams of boiling water at 100 degrees Celsius is poured into a glass containing 200 grams of water at 28 degrees Celsius. Calculate the final temperature of water. Now, something you guys need to take note is heat energy that is lost. Total energy that is lost equals to total energy that is absorbed. Or you can also say quantity of energy before equals to quantity of energy after, because it has reached thermal equilibrium. Okay, anywho, so right now we know that we're just playing with one variable, one thing here. It's not like a coffee and milk or something, it's just water with water. So we can actually cancel out the C. So we're left with M theta. And theta is referring to the change in temperature, right? So first, one of the water is at 100 degrees, and one of the water is at 28. So one of them must be reducing, right, in temperature, and one of them must be increasing. So over here, because it's decreasing, so it's 100 minus, let's put a y there as the variable. Next is because it's increasing, so we'll take the final temperature of this one over here, the 28 degrees, must be increasing, right? So that temperature will be y. So both of this is the same, right? Because it has to be the same temperature in the end. So y minus 28. So eventually, when you guys open bracket, like normally how you would do in maths, you will get like this. And when you solve it, 77.6 divided by 0.22, you'll get your answer. And it's only in 2 degrees, okay? Sorry, 2 decimal points. Last but not least, for part 1 of this video is relating to, it's the same type of question like just now, but I want to tell you guys, since there are many types of energy, another one to think about is kinetic energy. So the most common one that I've been seeing so far is electrical energy as well as kinetic energy. Now kinetic energy, the formula is 1/2 mv squared. Now be careful, because it can be elastic potential energy. It can be, so that you'll be dealing with other things. It's either 1/2 kx squared, it can be 1/2 fx, it can also be mgh. So these are all potential energy. But you'll get to that later, and usually it's not that hard, it's not that challenging. So usually it's these two. So let's see at this soalan here. A lead bullet moves horizontally with a velocity of 130 meters per second and embedded into a cement wall after collision. If the specific heat capacity of the lead is 130 and all heat produced is absorbed by the bullet, what's the increase in temperature? So heat absorbed equals to heat release, or heat before equals to heat after. So heat absorbed equals to heat release. So just take the two energies together. So one, we're dealing with the kinetic energy, so it's 1/2 mv squared, and one we're dealing with a change of temperature basically. So we want to know what's the increment, what's the change itself, not the temperature of the final or initial, but we want to know what's the increase of temperature itself. So we want to know the value of theta. And once you sub everything into here, you'll get your value, which is 65 degrees. And what is the assumption that you can make if the saw line eventually asks you? You can say that there's no heat loss to the surroundings. Don't forget to like and subscribe or share it with your friends who you think this might really help, as it helps increase the channel, as it helps with the channel algorithm, so that more people can get to know this channel. Bye guys!